So, right.
Hi, sir. Very good afternoon. Had
Yeah,
your
very
lunch?
good. Yes, I had. What about you?
No, not yet. As a mouth check, yeah, done.
Okay. Oh, sick. Huh? So you can see my screen, right?
Yes, yes.
Right. So let's actually. So from now, we are going to have discussion on Kubernetes, and so far we have discussed about Docker. I think all are created Docker containers. Have you ever created? Any one of you or all of you created Docker container and
Yeah, I tried.
you tried Docker container, and I know that the image size was
Yeah, yeah.
was huge,
So
almost.
yeah, I have to work on that.
Yes,
But it's working. It's good.
it's working, right? And what about Chandra? Did you get a chance to create a Docker container? Sudhakar, Ramaya.
Uh, no, my personal system, some problem came, sir.
Oh,
I'll trial and do it.
okay.
So office laptop, I didn't, because I don't have access to download the softwares and those.
Yes.
I'll try it in once I got admin rights in my office laptop also, I'll try.
Yeah. What is the configuration of your personal system?
Personal system, 8 GB RAM,
Okay.
i5, and second generation.
Second year. Okay. So you are using Windows.
Yeah, Windows, yes.
Okay. Okay. So
So
if you have any,
yeah,
if you
even,
have any,
okay,
yeah. Tell
sorry,
me.
sir.
Tell me.
Yeah, yeah.
Tell me.
Even office system also Windows only.
Okay. Yeah. So the best thing is I prefer to install Linux, Ubuntu,
Okay.
or CentOS on my personal computer
So in
because
that case,
that is
yeah, that
yeah.
case I need to create images, right?
You
I
don't
think.
need to create an image or VM or anything. Just download Ubuntu.
Okay.
Okay, if you have a USB drive, Ubuntu provides some USB drive kind of an installation. So I think you have to store some ISO file in your USB drive and try to install it through USB as the startup disk and
Okay.
install it. That way it works fine. Because particularly this kind of setup, okay, whatever this kind of setup that we are talking about, it's good to have Linux actually. Linux is the core for all this containerization or Kubernetes or Docker, whatever we call. Linux is the core. So better always have work on Linux rather than Windows or even Mac. I prefer
Okay.
Linux because all these tools, whatever the containerization tools we talk about, they were developed for Linux. They are not developed for Windows. First thing,
Okay,
they
sir.
were
So
developed for Linux. So, but later on, they have added something uh, to work on Windows. They have added some layers or they have made some changes and all. But basically, they were developed to run on Windows, so Linux. All right. So coming to the last session, we discussed about containers and all. So, I think some of you have created containers, some could not create containers. So, you know that container is a an isolated process. It's a process that contains its own network namespace, interprocedure call namespace, interprocess call, a namespace for interprocess communication, and the namespace for C groups are there that will isolate the processes and stuff like that. Network namespace, storage namespace. There are a couple of namespaces we already discussed. Because of this isolation, we are able to run containers, and container is an isolated process that runs on top of the host machine. Host machine is nothing but our laptop, or if it is in a data center, it's in a data center. It can be any server that you want to install and run all these things, right? So coming back to the problems with the containers, because any technology that is evolved, because they have found some issues with the existing technology, or they want to create some add-ons to the existing technology, or they want to ease the management of existing technology. The same way, containerization is one particular stuff. On top of containerization, they found that the data center always, cloud world is the cloud world, they say that treat the data center as your machine. So that is how they want to provision us. For example, you take a cloud account, you take an account in any of the clouds, Azure or AWS or GCP or any other XYZ cloud companies, provider companies. They give you access to their data center. So from your laptop, you access to the provisioned virtual machines, and you treat them that as if you are working on your own computer. So always the cloud administrators say that always treat data center is your computer. Treat data center as a computer. That means you should be able to manage all the services, whether it is storage or it is compute services or it is network services, all services you should be able to manage from your own, from a machine, from your computer. So containerization is something like that. Isolated processes work on top of host machine, and there are some issues that it's not issues, I cannot say issues, there are some drawbacks that they found that because they want to scale up and scale down the containers during scale up. Scale up means the number of containers will go from 1 to 1 million or 1 million to 1 or even 0. So scaling up is based on demand. When you talk about Google or Facebook, something like that, they may run containers in millions. So when you scale up or scale down your containers, it's very difficult to manage containers. It's too difficult because container gets one IP address. First thing, let's talk about first thing, networking thing. Each container gets an IP address. In our Docker example, we have seen that we can create our network namespace, or we can create our own network, and we can assign that network to our Docker container. What happens is it will work on CIDR rules, and it creates its own gateway, and then it creates its own IP address for that particular container, because container has isolated network. So as we know that containers are ephemeral, that means they may die. They are all, we have to treat them as something like bubble. Okay, they are short-living things. We have to treat them. I'm not telling that they are really short-living things. They may short-live or they may long-live, live long. But we always should think that containers are short-living things. What we call it as ephemeral. And so whenever you create a container, it gives you an IP address. Once the container is down or killed or terminated, in place of that, you create another container. It will not guarantee you that it will give you the same IP address. Let us say 172.17.0.1 or 0.1 is the general gateway for Docker networks. 172.17.0.2, if you give the container gets it got crashed, so you have to create, or you wrote a script that to create a new container. When the script is run, the new container may or may not have the same IP address. So generally, when we are talking about distributed computing, all the systems in distributed computing are connected through IP address. That is only the way all the systems are connected. We need to have an IP address. So based on that IP address, let us say my database is running on 172.17.0.17. Let us say my application server or my .NET core application is running on 172.17.0.2. It is running on. When I want to connect to my front-end server or my database server, I can connect only through the IP address. So the IP address may live long, may not. Okay, once the container is crashed, we may lose the IP address. That is one of the things. So managing IP addresses is very much important, which just with containers we cannot do. So who will create a new container if the container is destroyed? Let's say we have seen that our file upload application, what it does is we can upload files using that application. When there is a huge demand, I want to run the same application on more than one container. Let's say I'll run the application on 100 containers or even scale up to 1,000 containers. So who will manage those containers? That means I should always say that either an automatic rules or manually I say that this application at a minimum, it should run on, let's say 10 containers. So if the number of containers comes down, let us say the container, one of the containers has crashed. So the number of containers have come down to 9. So who will take care of creating try to fill that number of replicas, that particular one of the containers? So there should be a system that should ensure that proper IP addresses are given, that should ensure that if we say that this particular service or application should have 10 containers, 10 replicas, it should ensure that at any point of time, the 10 replicas are running. 10 instances of that application is running in the cloud or in the cluster. That means there is a lot of management related stuff that has to be handled behind the scene. It's not only just running a container. There are some workloads that has to be handled by some system, which should be something like an orchestrator. That's where actually Kubernetes comes. Kubernetes is nothing but it's an orchestrator. It's an open source software. So consists of different plugins developed and maintained by Google, but later on so many thousands of contributors involved in the project. So what Kubernetes does is that means it manages the entire ecosystem for the containerization. That means it's a platform. On top of this platform, containers will run. That means managing the containers, checking the health of the containers, probing that the container is ready or not ready, ensure that the container is split over different machines. Containers are created over different machines or different nodes in a cluster. Scheduled, let us say that if the traffic goes from let us say 1,000 requests to 1 million requests, immediately increase the number of containers. Suppose you write a rule. So based on that rule, it has to scale up the containers from 100 to 1,000. So where do you write the rule? Who will handle that rule? So all these things are taken care by Kubernetes. So it's very important component. Now, if you look at the cloud ecosystem, whether it is an on-premise cloud, that means the cloud has been especially created for your organization by your organization, or it's a public cloud, something like Microsoft Azure or GCP or Amazon AWS, or it's a platform as a service like Heroku or any other service, or it is an hybrid cloud between public and private, or it is a private cloud. Whichever the cloud it is, Kubernetes has become a platform for that. It has become, I can say that an operating system for running containers. So what operating system does? Operating system will give you, it gives the resources for the applications to run. Resources in the sense memory, so network resources, input output resources, whichever the resources that are required to run an application. Generally, operating system gives that. The same way on a cluster, Kubernetes gives all the resources. Right. We know that we understand that what is Kubernetes. So it's an open source application. It's an open source platform that is developed to manage containerization, to manage resources on the to manage container resources. It's an open source software, as I said. So that's what actually the Kubernetes is. Let's go and understand what is a cluster, what is a node. So how to create a cluster, how to create a node, so how to run our applications on Kubernetes. So this particular course, it goes like this. First, we have to know what is Kubernetes. Already we knew that what our containers are, what is a container, what is containerization, how to pack your application as a container and push it to the repository. That's what we understood, we learned. And then, now that is part one. We know that how to create an application. Already we are application developers. We know that how to create an application. Then now we already knew that how to package an application like an image and push that image to the repository. And we know that how to pull the image and run it as a container. This is step one. This when you see the path to learn Kubernetes, this is step one. When you go to step two, you have to know that what is Kubernetes. So what is a cluster on Kubernetes? How to work on clusters in Kubernetes? How to work on a cluster on how to work on Kubernetes on a cluster, whatever. How to create a node? What are worker nodes? What is the master node? What kind of algorithm that is used by the Kubernetes engine, entire ecosystem. Then how to deploy applications, how to deploy stateful sets, how to deploy cron jobs, how to deploy replica sets, how to deploy volumes, how to deploy services, how to provision the application to the outside world, how the applications or containers inside Kubernetes can communicate. These are the things we will discuss. And last, it's a training. Not only it's a training for, let us say, 2 to 3 months. It will take. At last, at some point of time, we will switch to how to develop serverless applications on Kubernetes using OpenFaaS or Knative or Fission. There are a couple of platforms. We will learn that. So first thing is what is Kubernetes? You have to understand actually what is Kubernetes. That's where we will start with. So there are some words actually we hear when we are in the Kubernetes world. When you are in an office, of course, you may or may not involve in any cloud-related cloud native applications, or you may or may not heard about data centers, clusters, and all. So with respect to to Kubernetes, the first thing is a cluster. So cluster is nothing but it contains a couple of worker machines, what we call as nodes. That means a cluster is nothing but it contains nodes. Nodes are nothing but all the containers will run on nodes. So in order to say that this is particular thing is a Kubernetes cluster, it should have at least one node. So one worker node, if any data in any cluster, anything has, then we can call it as a cluster. Let us say we don't have any nodes, we just have a machine, host machine. You have installed a couple of Kubernetes tools on your machine, then you cannot call it as a cluster. Cluster means a machine that contains a machine, or let us say in cloud, when we talk about data center and cloud terminology, in a data center or in cloud, there are some nodes. One of the nodes is a worker node. That node is installed on a cluster. That means cluster is it groups all the nodes actually. A group of nodes or even one or more, then generally we can call it as a cluster. Nodes are again, there is a master node and there is a worker node. So generally master node is different and worker nodes are different. We will talk about what is master node and what is worker node. Generally, that is what a cluster. So set of machines, set of nodes. If there are set of nodes, then we can call it as a cluster. You have any doubts about cluster?
Sir, one doubt about, as you mentioned, like IP addresses, once the contain like a Docker where we are hosting the Docker or like a application. So
Yes.
when it is crashed, then the IP it won't return. Then in that case, so we need to again configure the child like a master and child IP, same IP we need to configure, or how we need to like handle that IPs.
We don't need to do anything. Kubernetes will take care of that.
Oh, Kubernetes itself it will take care of.
Kubernetes itself will take care of that. We don't need to do anything about that. That's what Kubernetes does.
Okay. Like
Sir?
yeah,
Yes,
like a SQL server mirroring concept is there, right? Like a production and child and witness, like a once
Yes.
yeah, same kind of we need to like do the again configuration, but here the Kubernetes will take care, right?
Yes, Kubernetes only takes care of creating IP address, assigning IP address. Okay. So do you know the IP address of Google?
Yeah, some IP address is there.
No. Okay, let us say that. Do you know the IP address on which IP address we are discussing on? Do you know the IP address of Gmail? Do you know the IP address of Outlook.com?
Yes, sir. Some IP addresses will be there, but
Yeah, do you know?
yeah, I know. I forget, sir, but when we like generally people will be giving Google IP address some 192 something is there. So once we hit that one,
Okay.
then automatically that Google page will be coming. So
Okay.
that's what in the IP, if the same IP is not running, how the application is like running and showing the page.
Okay. So
Like if you come to Office 365, the IPs will be, I think, different. I think it's dynamically changing. I think I'm not sure.
yes,
Yeah.
IPs will be dynamically changing. It will not give you one IP address because there will be a reverse proxy and all. There are different concepts that the whole networking stack work on. So we don't know actually the Google IP address. Okay, there may be so many IP addresses for Google, and we cannot show. We are not sure that which IP address we have to connect to. Even Outlook.com also. What we know is we know only DNS. We know only the name of that. There is a domain naming server whenever we type something, for example, you type something from your browser, it will go to your gateway. It will go to your default gateway in your router from your browser. Then from there, it will reach the internet service provider. From there will be DNS servers. It will connect to DNS server, domain naming server. It goes there and search for what is the IP address for particular domain name. So that IP address is returned to again back in the same way, and then our browser captures that particular IP address, and then it will send request and response. So the entire cycle happens. Okay, that means we do not know the IP address. We never care about what is the IP address of Google. What we care about is it's a google.com is the website name. Same way, Kubernetes also provisioned something, some mechanism. Kubernetes has some core DNS server running inside Kubernetes control plane. The entire ecosystem will use. So what it does is, instead of taking care of IP addresses, instead of sending data or sending requests and receiving a response from an application, instead of hitting the IP address, what we do is we will call the service with the service name, which exactly work like DNS concept in our internet. Because containers are maybe in millions. Containers may be in millions. Maybe your application is running only 10 containers. But when we talk about Facebook, Google, or so such applications, the applications that are having millions and billions of requests and response cycles, they may be running millions of containers. So IP addresses, they cannot assign IP address, static IP address, or single IP address to any of the pod, any of the containers, right? So
Yeah, exactly, sir. So in that case, just I'm giving a example. In organization, they won't allow some kind of URLs, so that we need to raise a CRs and we need to give a URLs like as you mentioned DNS servers. So like Office 365, we don't know about the IPs. It will be URL direction. That's where just I'm recalling. Exactly. I understand, sir.
okay. So if you know about host directory in Linux system, I think in Windows also something is there, I forgot. There is a DNS resolution file, resolver.conf for some file. Even you can give your local host. Generally, what is the resolver for local host? Let us say you give local host. How it is resolved? It goes and search for your internal host server. What it is configured. By default, all local hosts are configured with 127.0.0.1. That means whenever you type localhost, it will redirect. It redirects to 127.0.0.1. That means it's a resolution. It's a domain name resolution. That the local host is kind of a domain name, and the resolution will be an IP address which is called 127 dot some blah 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 IP address we get. Same way, inside your machine, you can create your own resolver. Let us say you want to type google.com. I don't want to go to actual Google service. I want it to go to it should go to my own website that I have created. That you can modify the setting in your computer. You go to some host file configuration and say that when our user type google.com, instead of going to Google server, it has to go to some IP address or some container or some IP address with some different port number. It can redirect it to.
So,
Jitendra
sir,
sir,
Yes, sir.
Here one query is like in this case, so many containers, so many same IP address. The load balancing, we will use third-party load balancing, or we will inbuilt Kubernetes having the load balancing related stuff.
Kubernetes has almost everything. It has a load balancer. It has its own persistent volumes. It has its own workload related things. It has its own probes. Probes is nothing but something failed. It checks why it has failed. It keeps on checking. Let's say startup probe, readiness probe. There are some probes. So it checks for all those things. And it also notifies that something is not working, why it is not working. It also notifies the Kubernetes system that something is not working, why it is not working, and try to resolve it. So again, load balancers there are a couple of differences for load balancers. Load balancing inside the cluster is different than load balancing the traffic that is coming outside of the cluster. Let us say you want to hit your application from outside. So there will be a load balancer. There will be a cloud provided load balancer. Then it comes to the Kubernetes cluster. From Kubernetes cluster, there may be a load balancer, something called Ingress. Ingress is Nginx Ingress free open source load balancers are there, or there are some plugins available in Kubernetes that we have to take care of that. Okay. So,
sir, I have a question.
Yes.
These container IDs are unique, correct?
Container IDs are unique.
So yes, why can't we track it again, even if we lose the stuff? Why we are concentrating on the IP address? Can't we call back again with the same?
No. Container is destroyed. That is destroyed. That's it. You will not have any trace of the container.
Oh, so once that is closed, or then that's gone.
That's gone. That's it. If the container is closed, container is destroyed, container is terminated, whatever you call that's it.
So then what is the safety of using this? For example, so I know that we are linking it to some log or something, but
it's not a safety in the sense. Safety
like
in the sense
we are accessing this and doing some important.
That's what you have to use, persistent storage.
Okay.
Persistent storage is different than compute resources. These are all called compute resources. So something has to be processed. The request is coming, that has to be manipulated or that has to be processed. It will be processed. It has to be stored somewhere. You need to store it in a persistent
memory.
Storage.
Yeah, you told that last week.
Yes. So that's very important.
Okay.
So coming to the concept, there is a cluster. I told you the cluster means nothing but set of nodes. So node is nothing but it's a worker machine. So all the workloads. So the node can be installed on a virtual machine or physical machine or your host or wherever it is. So all your workloads, that means all your containers will be running on the node. Generally, in Kubernetes world, we cannot in Kubernetes we don't work directly on containers. We work on pods. Pod is nothing but a resource that has one or more containers in it. Okay, it's an abstraction on top of the container actually. So it's an abstraction. It will be created on top of one or more containers. Generally, we call it as pod. So pod is the smallest unit in Kubernetes. So in Kubernetes, generally we don't directly work with containers. We create containers, we create Docker files, or we create any container files. We post them, we ship them, package and ship them, push them to the repositories. But generally, we work with pods, not with containers directly. Okay, so each node is nothing but that's what a worker machine, a worker node, or a node that will be installed or configured on any physical or virtual machine, depending on the cluster. So it has a lot of services, daemon services to run the pods. That means ultimately, when we are working on Kubernetes, means the ultimate goal is run our applications in terms of pods. So all the pods are managed by the control plane. So each and every node has got some components, let us say kubelet, kubeproxy, and the container runtime. Let us say can be CRI or Racket or Docker. Okay. So let's go to, I have a pretty good diagram about on containers, on particularly on.
So, sir, actually, we cannot able to set up this environment in Kubernetes. Docker itself. So, if we want to use like a clustering and those things, then we have to use Kubernetes, right?
Docker also we can do that. Even in Docker we can do that, but Docker is not that extensible or that user friendly or whatever that robust as Kubernetes. Docker we can do that is called Docker Swarm.
Docker Swarm, yes.
Docker Swarm is a container orchestration engine. Using Docker Swarm, we can do some of these tasks, what Kubernetes does. But Kubernetes is for the heavy loads. I told you Kubernetes is being used as an operating.
Yeah, exactly. So, but Docker doesn't have this much of capabilities. As a user interface, we are going for the Kubernetes, right? It is Kubernetes Google one. So they're giving flexibility. That is the reason we have come up with Kubernetes as a maintain this kind of containers and connecting with the replicas and those things, right?
Kubernetes is not by Google, started by Google, but now it is an open source project completely. Thousands of companies, even including Microsoft, Google, Amazon, DigitalOcean, even the IBM or Red Hat, CentOS, all these companies involved in taking the Kubernetes to the next level. Okay. Without today's trend,
your voice is breaking.
Even for another 10 years, without Kubernetes, there is no cloud.
Okay. Because when we got one of the project Nike project, when they started DevOps with this one, during 2017 they said Kubernetes Google one and Docker own thing. Same Docker also we can maintain all the similar kind of activities using Docker. Then Kubernetes is a competitor for the Docker like that. I'm not sure. That's where I just.
No, Kubernetes is not a competitor for Docker actually. Maybe when they started in 2017, they might have, or the entire community thought of it is Kubernetes is competitor for Docker, but Docker is a container engine precisely. I'm not talking about Docker Swarm or anything. Kubernetes is a orchestrator. Okay, it's a manager. We can call it as manager.
Okay.
So when you talk about Kubernetes cluster, that means when you talk about Kubernetes, when you say that I'm working on Kubernetes, ultimately you are working on Kubernetes clusters or clusters. Okay. So cluster is the let's say heavyweight, the superset resource in Kubernetes. That means everything is a subset of cluster. So when you talk about the big picture of Kubernetes, generally when you go to an organization, they say that we have provisioned Azure or we have provisioned GCP, then this is your cluster. You have to create your cluster and work on your resources. Generally, they say like that. So what does a cluster contains? So cluster is nothing but, of course, Kubernetes admin has to set up the cluster. Or when you go to Azure or GCP or something, there are some tools to provision a cluster. So when you say that we have a cluster, that means it contains some nodes. So for high availability, there will be more than 2 nodes, there should be, let us say, high availability means that whatever happens, the cluster should not fail. Whatever happens, all the applications should serve. Okay, 24/7 applications should be working.
Okay.
None of the components should fail. Yes, sir.
Sir, actually, using the Kubernetes, then in the big organization or small organization, we can like a configure for the networking system also, right? How the network traffic is coming and going. So some in every organization they will see the network so using the some kind of monitors or diagrams, right?
No, Kubernetes is not used for networking. Not network filtering or network firewalls or not something. We cannot use Kubernetes for that.
Oh, okay.
Kubernetes is an orchestrator that is used to run our applications.
Oh.
Okay, only our applications we are supposed to run on Kubernetes. Okay, you can host your cloud-based applications or hybrid or local cloud-based applications. You can run on Kubernetes. You can publish to Kubernetes. We can make them run on Kubernetes, but Kubernetes is not for network monitoring. It's not for traffic monitoring. So when you talk about Kubernetes cluster contains actually all these components, but whichever the components we have, there is an API server, there is a cloud control manager, there is a controller manager, and there is HCD. That generally etc is the folder, you know, that in all Linux and Unix based system. HCD, that HCD, etc, HC we use it to store actually the configuration data in our system. Generally, whichever you install Kubernetes or Docker or one thing, all the config files are in general they stored in etc folder. In the same way, there is a persistence key value based storage component in Kubernetes that is called HCD. Some people pronounce it as ETCD. D means daemon, so ETCD, daemon. So there is a kubelet, there is a kube proxy, there is a scheduler, there is a control plane and node. So we talk from node to the whole system. So generally Kubernetes has inside a cluster there are some nodes. Generally we call it as worker nodes, and this can be called as a master node. So when you talk about any master and worker or master or slave, that concept, what happens is master is responsible for managing, provisioning, scheduling everything. If you talk about any in general any master slave concept, the purpose of the master is that. But in Kubernetes, generally we call it, this particular component we call it as a plane, control plane. This control plane has an API server. That means Kubernetes is very transparent. We can say unlike old Docker, not now. Kubernetes is very transparent. Transparent in the sense I'm not talking about only Kubernetes is open source software. Kubernetes is transparent means whichever the API server that the Kubernetes control plane uses, the same API server nodes will be used. The same API server as a client we can use. So even we can pass some curl commands or postman calls to this API server. That means what we do, all the request and response happens through the API server. For example, I say that create a node on the cluster. That means already the control plane is already available. I say create a node on the cluster. So you can send some request to the API server, even using Postman with proper details to create a node. So API server is the, let us say, it's a complete brain of the Kubernetes cluster, particularly control plane. So all the information about each and every resource inside the Kubernetes. So all the information means which
Sir, your voice is breaking, sir. Hello.
all the information. Hello, yes.
Yeah, your voice is breaking in between.
So guys, are you also facing the same issue?
Yes.
So how is it now?
Yeah, now it's good, sir. And one quick query, sir. So in the API, how much data we can able to hold, like a cloud providing API? So any limitation is there?
I didn't understand your question.
No, through API we will get some kind of data, right?
I'm not saying that we will get data. API is something like it's an API server. Okay. So that API server is used to establish communication between nodes and even the user.
Okay, got it. There is no like a get a information and a post information or
Get information and post information we can do through API server. All the data is stored. All the data is stored in etcd.
Okay. So what is the limitation of the using that API URL? How much data we can get at one shot?
It's actually the question itself is how much data you can get through SQL, how much data you can store in SQL server.
No, store in SQL server, I think more than lakh.
No, how much, I mean, data you have to tell in the terms of TBs and GBs and TBs. How much data you can store in SQL server?
TBs, I'm not sure, sir.
Yeah, it depends on the storage capacity. Okay, it depends on the storage capacity. Let us say that your SQL server has the capacity of only 1 TB data. You can store only 1 TB data. Okay, if it exceeds, then you have to provision some more disks, or you have to purge the data or send it to some other storage or whatever it is. Generally, these are all old practices companies do. So there is no limitation that you can store only this much of data. Because there is no limitation, because we don't want to limit anything, that is the reason we are using cloud. So here, data in the sense, I think you were thinking in a different way. Data in the sense, the API server is used to communicate. It's a server where let us say that you develop an application using .NET. It's a web application. Where do you store all the data?
Yeah, the storing the data is in the SQL server only. But when we are coming with the REST call, REST API having the limitation that URL limitation is there and the data limitation is there. We cannot able to get at a time 5,000 records or
Okay.
2,000 records. I'm not sure about maybe 200 records only. After we can write a different kind of logic and again we call the URL and passing the parameter so that we can get a huge data. And sometimes what happened, the people will be doing the pagination. After pagination, again they will pass the server to the data, pass to the query and get the server again the page next page. So such a way they are handling the loading and like displaying the data. But at a time, the single shot, we cannot able to get 5,000 records also. I'm not sure.
Why can't we get? So what is stopping? No, that's what I'm telling. Why don't we get? What is stopping you not to get? There may be something that is stopping, right?
I'm not sure, sir. That is where I am just because
That means your computers are not powerful enough to process the data that we requested.
Even initially also 250 or something is there. Then when we do indexing, then only we will able to get 5,000 records. That is
No,
the limitation.
I don't know. I don't know that there is 5,000 records limitation, because I have fetched many times even lakhs of records, thousands of records, many times. Many times I fetch thousands of records. The only thing is processor may be busy, or your query may be taking a lot of time for that. So there may be timeouts. So you have to handle timeouts. But I never found that. See, there is a limit for everything. There is a limit for everything. But here, this API server is not to store your application data. This API server is used to store the data that is related to your Kubernetes. That means how many nodes are there? What is the configuration of the node? How many pods are there? What is the configuration of the pod? In what state that you want to run your pod? Let us say you want to run containers, 10 containers. Forget about pod. Let's talk about containers. For your application, you want to run 10 containers. So this says this, okay, application A should run 10 containers. And this is the container ID. This is the image of the container. This is the volume that has been included, attached to the container. That kind of data. Data in the sense, this is not the application data that this server will become too huge that you cannot handle. This is not application data.
Okay, got it.
This is not application data. This is the data related to Kubernetes.
Okay.
Probably Sudhakar asked about payload. Are you asking about the payload?
No, I don't know Taylor. I'm asking related to application data. As Jiten sir is clarified. Actually, I got it.
This is not application data.
Yeah, because in SharePoint always we get application data using the REST calls. In REST call by default 200 only. Then certain way we will write a data and we'll write a logic. Then 4999 will get it. But 5,000 also it's we cannot able to get it. After we'll next URL something kind of logic will write, and how much, as I Jiten mentioned, right, Jiten sir, like application, how you time out, and I got it, sir. Thanks for that.
This is not related.
To reduce the page response time, you will use the pagination. So if you call like 1 lakh records, it will take some time to display, right? That's why you use the pagination. You get whatever the records, like if you have the limit like 2,000 records, you just display 2,000 records. When they click pagination, you just pull the another 2,000 records.
That's way off.
That is only for showing, correct? Displaying.
Yes. Yeah, displaying.
So here, this is not the application data. One thing you have to understand is this is not application data. This is the data that is related to the entire your Kubernetes system. So the whole cluster contains some data, right? How many pods are running, how many volumes are attached. So how many pods are scheduled, what is the state of the pods, what is the health of the pods, what are the containers, what are the jobs, what are the cron jobs, and what are the daemons, what are the deployment sets. These kind of data, these are all the objects or resources. Generally, we work in Kubernetes. All the data that is related to these resources will be stored in etcd. etcd is a key value store database. Key value store database kind of a thing. I think it is in memory. I'm not very sure. I think we can store it as persistent as well. etcd. So this API server.
Like that.
Yes, this API server will talk to etcd. Let us say you send a request to create a pod. Let us say you send a request to create a pod. Then that request goes and stores in etcd. Okay, this is the pod that you have to create. Then there will be a scheduler decide that, let us say, uploader application should install 10 pods. Let us say uploader is an application, app, service that has to install 10 pods. That means 10 containers should be running uploader application. Uploader instances, 10 uploader instances should be running. What? So as a user, you send the request, create 10 resources using a file or using command line. 10. The data is stored in the etcd. There will be a scheduler. What the scheduler does is, the scheduler decides.
Baby, she's trying.
So this scheduler is responsible for scheduling the particular job. So we know what is API server and we know what is etcd. This is the API server. This is a etcd database, the data store, and this is a scheduler which is scheduling the everything. And there is a controller which is used to control the entire control plane. That means whether everything is running or not. Okay, keeps on checking and make sure that everything is working fine or not. The entire control plane is checked through the controller. So these are all the components that we have in the control plane. This is called control plane. So, and another one is cloud control manager. For example, this Kubernetes cluster is connected to, this Kubernetes cluster is running on a cloud, Azure or GCP or AWS. They provide their own controlling manager, cloud controlling manager. It's a third-party cloud controlling manager for their extended functionality. But when you talk about cluster control plane, these are only the control plane.
Sir, diagram not showing, sir. Not visible diagram.
Guys,
we all can see.
Okay.
Are you able to, Sudhagar?
No, I'm not able to see the diagram actually.
We are seeing it. Chandra, what about you?
Yeah, able to see.
Yeah,
we can see the diagram.
Okay.
right. So this is what the control plane, very important actually. Okay. For example, usually what happens is there are two things. One set of people are administrators of the cluster, Kubernetes administrators. One set of people are users of the Kubernetes. So application develop. Hello. Hello.
sir.
Can you hear me?
Yes.
Yeah, I think somewhere, please switch off the mic. Somewhere I'm getting some disturbance.
Probably Chandra.
Yeah. So remember that the whole thing is called control plane, very important. So each and every Kubernetes cluster must have this control plane. Unless there is control plane, Kubernetes cannot work. And coming to node, actually nodes are the places where all our workloads should be running. Let us say I say that 10 containers should run on for my application, then those 10 containers will be running on nodes. So the scheduler will take care of which node is available. We can provision which node to which node we can provision this. We can ask which node to create all the containers and all. On nodes only containers will be running. Right. So each and every node will contain two things. One is kubelet. and the other one is kubeproxy. So now I think you are able to understand the entire thing is called cluster, and this is a control plane. We can call it as a master node, and these are all the worker nodes. Each and every node has two Kubernetes components. One is kubelet, and the other one is kproxy. Kubeproxy. Kubeproxy is responsible for creating IP addresses, forwarding traffic to different ports, taking care of the whole networking inside the node. Taking care of the networking inside a node is taken care by the kubeproxy. And kubelet is responsible for make sure that it's not only to make sure, it is kubelet is responsible for creating and running pods. Scheduler is only to schedule. See, you can see that. Creating pods, creating all the workloads. Workloads means pods or any other stuff. Going forward, you will understand what is workload. Think of container as of now. Creating containers, running containers, everything is taken care by kubelet inside the node. So creating nodes is not taken care by control plane. That is the very important thing in Kubernetes, because here it is only to ensure that which node has to do what. It's only scheduling and providing API server and providing data. This is not going to take care of creating pods or creating containers inside the node. Kubelet has to take the responsibility to create pods, to create containers. So let us say that each and every node has an IP address. It has a node name. Nodes are nothing but generally nodes are installed across different machines or different host machines in general. I have 3 nodes. That means I have 3 different IP addresses. Each and every node has got IP address. Machines are even virtual machines as well. And when the Kubernetes administrator creating a cluster, he should ensure that each and every node has 2 components. One is kubelet. Kubelet is responsible for creating pods and all, and the other one is kubeproxy. How does kubelet know that what kind of pod it has to create? So what kind of pod has to be created in which node is stored in etcd? Kubelet cannot directly talk to etcd. What kubelet does? Kubelet is continuously communicating to API server. API server which goes and checks what is there in etcd. Let us say that node 1, node 2, node 3. Node 1 has to create 10 pods of uploader application. Node 2 has to run actually 20 pods of the, let us say, some registration application. Node 3 has to run 30 pods of a customer care application, for example. Or even we can replicate. There is a replica set. That means, let us say the uploader will install on the same uploader 10 node, 10 node, 10 node, 10 pod, 10 pod, 10 pod will be there on all 3 nodes. There is a concept like that. That is for high availability and stuff like that. That is ideal way. Kubelet goes and requests API server. What I have to do? API server checks inside the etcd that what kind of pods, workloads it has to configure, synchronizing with the scheduler. And the information comes back to kubelet, and kubelet will start creating pods and always sending the status of the pod, whether it is running, it is died, and everything to the API server and then to etcd. Scheduler will be keep on talking to API server and etcd and getting the data whether the pod is died or the pod is alive. If the pod is died, immediately kubelet will send the information to API server that pod is died. It will be stored, the status will be stored in etcd, and the scheduler will think that will say that the pod has died, so it has to create one more pod. It schedules, and whatever is scheduled, kubelet will go and talk to through API server and create a new pod. The whole communication inside pods, inside the node, the whole communication, network communication inside the node is handled by kuprox. Yes, sir.
What is pod?
Pod is an abstraction to the container. So we know container, right?
Yes.
Yeah. For now, think that pod equal to container.
Okay.
For now, in Kubernetes world, pod is an abstracted entity. Okay, it contains one or more containers, but let us assume that that is the smallest unit in Kubernetes.
Okay, so that means that only that one node will have a specific IP. All the container inside that node will run with the same IP.
For example, each and every node has 111 IP. 3 nodes have 3 IPs.
Okay.
So that means the traffic comes to node through node IP address. Then inside the node, there will be a port forwarding for each and every pod. Each and every pod has its own IP address. So the complete port forwarding, that means data will be coming through one port and it comes to node. Everything is taken care by kubeproxy.
So that is taken automatically by Kubernetes.
That is, yes, kubeproxy is a component that kubeproxy is taking care of each and everything.
Okay, got you, sir.
So you can see that kube control manager. You can see here kube control manager. Kube control manager is a component that runs all control processors. That means all the control plane components will be taken care by kube control manager. And the other one is kubeproxy. It's a network proxy that runs on each node in the cluster. That means each and every node should have a kubeproxy component. And other one is kube scheduler. That is what we talked about. Kube scheduler is control plane component that is there in the control plane that watches for newly created pods with no assigned node and selects a node for them to run on. So whichever we say that create a pod, that goes to the kubeproxy, that goes to API server, then scheduler will say, okay, I got a request to create a new pod. So it says that, okay, node 1, go and create the pod, or node 2, go and create the pod. It uses some algorithm, round robin or some algorithm to assign tasks to each and every node. Kubelet is an agent. It runs on each and every node. It ensures that the pods are running in the pod. Pods are running inside the node. It takes pod specs. What is the configuration that we have asked? Based on that, it ensures that pod specs are run. That means, let us say we say that Ubuntu container. It checks that, okay, Ubuntu container is running and it is healthy. Something like that. And this is the heart, Kubernetes API. So entire API runs on RESTful interface. So even all the components in the Kubernetes itself talk to the same APIs that even we also going to talk. And the last component is namespace. I will tell you what is namespace in a little while. So first thing is, if you want to work on Kubernetes, you need to have a cluster. That cluster should have a node. To create a cluster, creating a cluster is nothing but you need to create, there are some components you have to install, and there should be one or more nodes. For development purpose, one node is enough. But if you are in production and all, generally 3 nodes are advisable. Minimum 3 nodes are advised inside for a cluster. Some companies, they run each and every business unit in a separate cluster. Some companies run even each and every project in a separate. Some companies, the whole applications run in one cluster on different nodes. It all depends on the load and all. Generally, cluster is created by the Kubernetes admin. There are 3 ways that we can create a cluster. 3 or more ways to create a cluster in our for development purpose. The first one is Minikube. So most probably all of you will have to install Minikube. Other one is K3, kind. MicroKits. K8 generally call it as kits, MicroKits. So Minikube is one thing. Most probably you have to install Minikube. So to install Minikube, you need to have a virtual machine. If you are on Windows, of course, if you are on any operating system, you need to have a virtual machine. If you have Docker, you can create kind. In the Docker itself, you can find some option. If you go to Docker properties and all, you can find an option that enables Kubernetes cluster. Can you see that? There will be an icon. There is an icon that is running on top of Docker, that on top of your what do you say, the toolbar, title bar, right? Windows title bar. If you click on that, you can see that Docker icon. When you go to the properties or preferences, you can see that enable Kubernetes cluster. Okay, that means it will use the Docker based kind cluster. You can run on that. The other way is MicroKits. It's micro K8, but people pronounce it as MicroKits. So MicroKits again, it requires Ubuntu or Linux distribution. Unless you have Linux distribution, you cannot run MicroKits. If you don't have Linux distribution, you cannot even run Minikube, even kind, even K3. All 4 needs to have some Linux distribution. But kind and K3s, I think kind, Docker, whenever you create Docker, it will create its own virtual machine and it runs Linux on top of that. So you don't find it as that you are manually creating a virtual machine. That is the reason it asks you to enable hypervisor, Hyper-V or VirtualBox when you try to install Docker. So Hyper-V or VirtualBox is nothing but virtual machine. It creates a virtual machine. On top of the virtual machine, it creates a Docker engine. On top of Docker engine, it creates something like kind Kubernetes cluster that run along with the Docker. So Minikube, you have to manually go on provision. I think Minikube also you don't need to do anything. With a simple script, you can run Minikube. And my favorite is MicroKits. MicroKits is very easy to install. If you don't have a virtual machine, if you don't have Ubuntu or any Linux distribution, what you need to do is you need to install multipass. There is something called, if you go to the website, you can see that MicroKits, 0 OPS, 0 operation, high availability.
Sir, can you please stop sharing and again share it? No? I'm unable to see. Maybe my office teams are not allowing, or I'm not sure.
Can you want to cut and again connect it back?
No. I disconnected and again connected, but it's not. I'm unable to see the screen, but I'm able to see your just image only, like a J. Stop sharing and again share it. No? It might be help you.
What about now?
Yeah. Now I'm able to see.
So you go to MicroKits. Canonical is a company. Canonical is a company that has created Ubuntu. So they have created MicroKits, which is zero OPS, zero ops high availability cluster for Kubernetes. It's very easy to install. So you can see different options. If you're on Mac OS or Windows or Linux, Linux is very easy. You can go and install on Linux. But if you're on Windows or Mac OS, so you can see download the installer for Windows. Okay, run the installer, open the command line, and all the steps that are required. So for Windows, I think you may have to install multi-plus or something. For Windows, you have to install something called multi-plus, some other tool that is a virtual machine for Ubuntu. On top of that, it will install MicroKits. So for Linux, it's very easy. There is a for Linux, I install MicroKits. It's your choice. You can go and install Minikube or MicroKits. But I feel MicroKits is very less weight. It's a lightweight component. Snap is a package manager like apt-get and all. Snap is a package manager for Ubuntu. So I go and just install sudo snap install MicroKits. So it's going and installing MicroKits. That means it is going and installing a cluster for me. So installing a cluster is nothing but it installs even a single node. So I go and check snap. So I just type MicroKits is the command. What I can do is MicroKit status. So I have to start the MicroKits. I said the MicroKit start. That's the command to start. You don't need to much worry about these commands because in real time in production, actually your administrator will give a cluster for you, and there is a separate guide to create a cluster for production usage. That means you need to create a different nodes, and I think some people are even using MicroKits for production in a different way, but that is only for IoT and IoT projects. So me check. It is not properly installed, I think. I'm trying to stop microkits and then delete it. Let me install once again. So installing microkits is nothing but creating a cluster. So creating a cluster means it installs all required control plane components and a node, and that node contains kubelet, which is an agent inside the node, and a kube proxy. Kube proxy is a network proxy which is used to distribute the traffic, incoming traffic to the node based on the application, and based on the port of the application, it will distribute the traffic. Right. Snap, install. I can copy paste. So microkits is going to be installed. Let's wait for a while. Right. So microkits 1.19 stable release, version 1.19.2 from Canonical has been installed. So microkits status. So microkits inspect, it is just for deeper probe, deeper inspection. It says that cluster agent is running, container D is Docker container, container D is a runtime. Like we need to, for on each and every node, one more component actually we mixed. On each and every node, there should be a kubelet, there should be a kube proxy, and there should be a container runtime. Container runtime in the sense it can be Docker, it can be container D, or it can be Racket or something. So, me to forward accept the IP tables, that is for IP configuration, and we can ensure that it is asking that to enable IP addresses, IP table related stuff. So these are all the components, actually subcomponents, subcommands for microkits. Microkits contain some components as well. I said microkit start. It has to start the microkits. Then what I do is each and every client machine. That means you have a cluster. Inside the cluster, you have control plane. In that control plane, there is a API server running. So whatever you want to do on the node, you have to talk to API server. The same way Docker has a Docker daemon running, and how can you communicate to Docker daemon? By using Docker CLI. In the same way, even in the Kubernetes, there is a CLI. That CLI is called kubectl. Some people pronounce it as kube control. Kubectl or kube control is a command line tool that is used to communicate, to create resources, to delete resources, to manage resources, or that is used to communicate to the API server. If you are very good, you want to know more and all, you can even go through your Postman and do that. But this is the ideal way. From the command line, even in Docker also you can do Postman. You can take Docker API is running. You can go and pass all the commands through your to the API, and you can execute that. So usually when you install Minikube, you have to install kubectl command separately. But microkits kubectl is also installed as a subcommand. You can see that. So how can you use that? First, I want to do the what is my cluster information. Microkits is kubectl cluster info. So kubectl is a subcommand inside microkits. There are two ways. You can even run subcommands like this. Microkits.kubectl cluster info. It says that Kubernetes master is running on this particular IP address. That means you can think of this is your control plane address as of now. Of course, it's not control plane, it is an API server running on this IP address, but think of this the control plane, right? You want to know more information, what you can do is for info dump. It gives you the whole information of the cluster. So every time you cannot go and type microkits.kubectl, what you can do is snap package. Microkits is a snap package. You can have snap, alias, microkits.kubectl k8. What I do is whenever I type k8, automatically it goes and runs this particular command. You need to sudo this. So now I can simply type k8 instead of, and most of the commands in internet, they are with kubectl command. So I want to name as this one. That means if I type k8, it will run kubecontrol or kubectl. Even if I type kubectl, it will give the same command. I created two aliases. Otherwise, what I have to do, I have to go on microkits.kubectl command. That I don't want to do. I want to use it easily. So k8 cluster info, my cluster is running that. Dump, it gives the whole cluster information. This is all the data that is stored in etcd server about your cluster. This is all the cluster information. So it gives you the dump list of the nodes. This is the node name is, this is the metadata of this particular thing. This is the node Jitendrandah. This is where the node is created. These are all the information about the node. Like this, it gives the whole cluster information. How many CPUs are there in this cluster? How much memory is there in the cluster? How many pods? Okay, for this I don't know, capacity, maximum 110 pods it can run with this memory. Allocatable, how much memory we can allocate. Okay, like this we can have, this is the node address actually. This is the internal IP and this is the node address. This is the IP address of the node. So it's a host name, node address is this. These are all the information it gives about the node when you say cluster dump. So first, what you do is cluster info. Next, what I do is I want to know about the information about my node. Okay, get nodes. It gives you the list of the nodes inside the cluster. You can see that in a data, there may be 1,000 nodes or 100 nodes. Ultimately, from your machine, from your laptop, you should be able to fetch the entire information of the nodes. How can you do that? You can do with the get nodes. K8 or kubectl. Describe node. That means you are asking for node information. What you can see, this kubectl or K8, you can put anything. Describe node. You are asking for the more information about the node. So you are asking for more information about the node. You know that the name of the node is this. This is the name of the node. Kubectl describe node. Anything. Kubectl describe name of the resource, type of the resource, and name of the resource. If it is a pod, kubectl describe pod, name of the pod, like that. So the name is this. These are the labels for purpose. These are the annotations. This is the created time. Okay. And these are the network unavailable. These are the states actually. These are the conditions and the state. Okay, it gives all the when it is ready. This is the time it took 11 seconds actually, but 10 seconds to be ready. You can see that this node took 10 seconds to be ready, the whole node. So 8 CPUs are available. This is the storage in my 110 pods you can happily create. So this is the machine ID, this is the UID that is created, this is the boot ID that is created. Kernel version is this, Linux kernel OS, operating system is Linux. Container runtime, it is using container D. Like Docker, there is Docker created some open source container that is called container D. This is the container runtime. No need to install Docker as well. Okay. And there are some namespaces. This is a concept that I will explain you later. There are two namespaces. This much of CPU, 3% of the whole CPU it is using. It used for this particular namespace. These are the resources that are allocated currently for this particular node. And these are the events that happened in the node. So kubelet has been started. You know that kubelet is important. So kubelet has been started. And there is a warning that invalid disk capacity, and all. Then node has sufficient memory. It is checking whether the node has sufficient memory. The status is node has sufficient memory. Again, it is checking sufficient disk pressure, sufficient PID, process ID, and starting. It checks all the things, and it starts the kube proxy here, starting the kube proxy, and it is making the kubelet ready. So by the time kube proxy has started, Jiten Ubuntu status is now node is ready. You can see that it takes 36 seconds altogether for doing everything. So if you talk about the DNS, it doesn't have any cluster DNS. So kubelet does not have cluster DNS IP configured and cannot create a pod using cluster first policy. So there are some network policies that it has to apply. So it is not using any cluster first policy. So now what we have to do? We have to see that what all resources that are running in my system. What all resources. Ki get all resources from all namespaces. Namespace is very important actually. Namespace is nothing but isolation of resources inside the node. Let us say that any team, for example, we got a cluster from Azure. My team is working on network traffic control application management. Some other team is working on they are working on user management or subscriber management. Some other team is working on subscriptions or licenses. There are 3 teams. So 3 teams have their own, all the 3 teams are using the same cluster, but their resources are different. I have my own set of ports. I have my own set of IP addresses. Everything is different for 3 of us. For example, if I want to delete my applications, I can go and delete my applications. It should not delete others' applications. So how can you do that isolation process? That isolation process can be done through a concept called namespace in Kubernetes. So namespace is an abstraction that is used by Kubernetes to support multiple virtual clusters on the same physical cluster. That means there will be only same physical cluster in Kubernetes. The cluster is same, but virtually you can split the entire cluster as many virtual clusters as you want through the namespace. That means you can have a number of namespaces. You can create our own namespace to create your own applications, to create an applications which are related to you. That we will see. That is what namespace is. For example, as of now, what you have to think is your team is working on some set of applications which are not related to other teams. Then your team can create your own namespace, and all the Kubernetes resources, that means all the containers, all the pods, all the services, you can create inside your own namespace. It's pretty easy. You don't need to do specially anything to create. So first we'll see what all namespaces that are available in Kubernetes as of now. Ki get namespaces. So there are 4 namespaces already created by Kubernetes. There is a short name. There are short names also as well. You can simply give ki get ns. No need to give namespaces completely. So there is a kube system, precisely a Kubernetes system namespace. Kube public, it's a namespace that is created by Kubernetes. Kube node lease, that is again a namespace that is created by Kubernetes. If you don't specify any namespace and create your resources, all the names and all your resources will fall under default namespace. Just to keep note of namespace in your mind. We will see more about namespace. It's very important. So you know now, right? You know how to see cluster information. Ki get ki cluster info, and you know how to create node information. Ki get nodes, and you want to know more about node, particular node. Ki describe node name. It gives the whole information about the node, and you can see namespaces ki get ns. Now I want to see all resources in my Kubernetes in all namespaces. You can even provide some permissions. Cluster administrator can give permissions that only this person can work on these namespace kind of. K8 get all from all namespaces. So you can see that actually when you say that K8 get all from all namespaces, it is shown that all the resources, all the objects that right now Kubernetes has. What are all the objects? The first two are pods. One is kube controller and Calico node, and the kube controller Calico kube controller pod. Two pods are there. They are running. The status is the first pod has restarted once 18 minutes ago. So since 18 minutes they are running. The second thing is a service. It's a Kubernetes service. The second thing is Kubernetes service. We will talk about services. Services are nothing but the networking components. So to enable different pods communicate each other or expose it to the external world, we have to create a service. And the other thing is a daemon set. We will talk about daemon sets later on. And the other thing is a replica set. That means we're gonna replicate all the particular resources across all nodes. That is called replica set. Let us say I told you that upload is an application. I want to publish that application on all nodes. Then we have to use replica set. Otherwise, scheduler will decide on which node it has to be deployed. Okay, you got it right. These are all the resources in the Kubernetes right now. So when you talk about K8, these are all the basic commands. These are all the basic commands. Create a resource, even from the file or through the command line. So expose, take a replication controller or a service, deployment or a pod, and expose it to new Kubernetes service. Run a particular image on the cluster. Set specific features on the existing objects. These are all the commands. We will talk about, we will see all these commands. As of now, just to see this. So logs is something that to print logs on the container. Describe is, we already saw what is describe. Attaching a running container to that, executing like Docker exec we can use. Port forward is the command that is to forward some port. From one container to other container, we can copy files. There is authorization related thing we can apply on the particular resource. These are all troubleshooting commands. So the other set of commands is apply difference against the different versions. We can apply them, labels. Okay, we can like what kind of API versions that we are using. A lot of things we can see in this particular set of things. Now, K8 create I put. There is a first command K8 create. So what you can create using K8 command line interface. You can create a cluster role, you can create a role binding, you can create a config map. That means you can store all the configuration, entire configuration for a particular application inside the config map. You can create a secret. Secrets are not exposed by the administrator. Secrets are created and you can consume those secrets, or you can create your own secret and consume. We can create a namespace. We can create a job. The earlier we can directly create a pod in Kubernetes, but now they allow us to create a pod using these deployment, job, replica set. There are certain things to create pod. So they don't encourage creating pod directly, because if you create a pod directly, it will not be managed by Kubernetes. Pod should be created through any one of this job or something. So okay, create job. Okay, create job. Let's see. I want to create a container, busybox container. What I can do is create job. The job is, let's say, my box is the name of the job.
Sir, can you scroll down a little bit down?
Nothing is there, right?
I think so. The scroll bar is there on the right side.
No, Jay. For you only it is there. For me, it's not there.
Oh, really?
Yes.
But I can't scroll it. I can't see actually.
You can't see anything?
No, I can see your screen, but I can't see what you are typing. Probably if you clear that.
I cleared already.
No, then it's stuck for me. It's stuck.
Yeah. So what about others? Yeah. So okay, create a job. You can see I just want to use some busybox. The job is my box, let us say, and the image I'm going to use is busybox image, and we can print the date that busybox when the busybox is created. You know that we already worked on busybox in our Docker demo. So I'm going to create a job. The job is nothing but creating a container from this particular image, and it has the arguments as date. I just wanna pass the argument as date. That's it. You can see that job.batch, my box is created. Ki get pods. You can see that a pod is created with some name. Pods are created with arbitrary names. It's not like it creates a name with random names, not arbitrary. It creates names with random numbers. So my box hyphen DWK8PL is the name of the pod. And now the pod is not created. The container is getting created. You can see that.
Jitu,
What
I think
happened
the
was,
screen is still stuck. So I don't know for others.
Yeah, for me also same.
Jitu, you just stop the sharing and
Hello, sir. Chandra, hello?
Yeah. Hello.
Yes. I think Jitendra sir is not.
Yeah.
Hello. Hello, guys.
Sir.
Can you see my screen?
Yes.
So where have you lost?
Yeah, I think that's okay. You explain here actually.
So what we have done is we have created a new job to create a pod. So I think can you see this right now, right?
Yeah.
Yeah.
Chandra, recording is working, correct?
Yes.
Yeah.
Okay. So it's like creating pod is we could able to create a pod with the old version of Kubernetes, but now they removed. So actually executing workloads is nothing but ultimately it will create a pod. Workloads are nothing but jobs, deployments, cron jobs, replica sets, stateless, stateful applications, stateful sets. Everything is ultimately to create. So the very simple way to create a pod is kubectl create job, name of the job, followed by the name of the image. For example, we want to run our upload application. It could be a upload application image. I'm using BusyBox. And the arguments that we want to pass here, the argument is very simple argument. I want to just pass the date, print the date, nothing else. I want to pass a Unix command, something called date, something like that. When you type date in Unix, it prints the date, the same thing. I want to do that. Here, the job is created. The job.batch and the mybox.one is created. K get pods. So two pods were created. The old one was earlier one. I think you might have not seen that when the screen got stuck. The second one we just created. What this particular pod did, this pod was created by this pod, and we did not say anything. This image, what it happens is, even our old BusyBox image, the image is created and pod goes to the sleep mode because we did not say the pod to do anything else apart from printing the date. So the same thing happened here. So how do you know that the pod has printed date? Because we have only pod and we see the status as pod is completed and there are no restarts. It has done, I think, few seconds ago. And always, I did not mention the namespace here. That means it is created in the default namespace. Remember that. For example, I say k8 get pods. I say all namespaces. It prints the pods of all available pods in all namespaces. But here we want to print only default namespace -n and name of the namespace default. We got 2 pods. Now I want to see the logs of the pod because it says that the pod has completed its execution. Here the pods are running, but this pod says that it is completed. How can you do that? kubectl or k8, I put alias name, kubectl logs. Name of the pod, mybox1 WLS7Q. This is the log of the pod. What the log did here, it has this particular job. What it did, it created a container, it created a pod, and executed the command date, printing the command date. So when you go through the logs of that particular pod, we could see this.
Sir, where is control plane?
Control plane is a conceptual thing.
Oh, that is internal. That is internal, nothing to create. It's automatic.
Control plane is a conceptual thing. Control plane means inside the node it contains.
Oh, okay.
Master node.
Because I kept that picture in my mind. I am thinking. So whatever picture you showed.
Yeah. So if you go to that picture, what we were talking about is go to this. When you say microkits installation, microkits has installed this particular control plane. Microkits has installed one node. Microkits installed kubelet, containerd, kubeproxy, scheduler, API service, control manager, okay, control manager, and etcd. These are all created by microkits. We are not creating anything, but what we are creating is inside the node, we are creating pods. As an application developer, what we have to do, we have to create our applications, we have to run our applications inside pods. That is the reason we have created that. Got it?
Oh, okay.
You can see that k8 describe node. Name of the node is, you can see that this particular node has kubelet command, and it has got a kubeproxy. You can see kubeproxy. This node has two things, kubeproxy and kubelet command. Because this is only the node information. This is not the information of the entire cluster. If you want to know the entire cluster information, you have to see cluster dump. If you want to know the information of the cluster, you have to see cluster dump. This is the node information inside the node. We are working only inside the node. We are not working. We are working only inside the node. That we need to understand that. So we got kubelet and we have got kubeproxy. Right. So now I want to run one more job. Let's say job 3. And instead of date, I want to put sleep. That means I'm creating a new pod that should start with my box 2, and the image is busybox image. And what it has to do as of now is just 3000 milliseconds on, I think, 3 minutes or 30 seconds. 3000 by 1000. Most probably 3 minutes. What we can do is we can go to get pods. Now we have 3 pods. You can see that since we say that sleep for some time, it is sleeping. We can use one command called watch. By default, watch what it does is for every 2 seconds it calls the same command. You can see that here the time is changing. Did you see? Watch what it does every 2 seconds. When you say watch and call the other command, every 2 seconds it calls the same command. So we created a pod, and what the command of the pod? But the command of the pod is sleep for 3000 milliseconds. So it is still running for 3000 milliseconds. For example, you are creating our uploader application, then we say the uploader application has to be up and running. It will always be running. If it crashed or it is completed, that means there is something wrong in our application. That should always run. It should be always in the running condition. Then only our application is working well. Our application is executing. And Kubernetes will keep on checking whether the application is running or not. It is supposed to run. It checks whether it is running or not. Everything is taken care by the Kubernetes engine. Let's put it aside, this one. So purposely, sometimes I'm typing kubectl, and sometimes I'm putting kh.
Yeah, sir. Here the Kubernetes, how the log shipping, how logs will be generating, how we will configure the logs. That will be taken care by administrator. We don't do, right, as application development
No,
team.
we don't need to do anything about logs. If you want to see logs, you can go and see the logs. If you want to see, there are so many tools for logs. Okay.
It means third-party tools you're talking about, no, sir?
There are third-party tools and there are internal tools for logs. Some people send their logs to Elasticsearch.
Okay.
Some people send their logs to Datadog. Some people send their logs to just write it as a JSON format. Some people send their logs to Splunk, which is a third-party tool. So there are so many ways. But ultimately, Kubernetes stores all its logs in the node. Okay, there will be some file in the node. All the logs are stored in that particular file. We can go and search, or we can write our own tool to periodically. Even we can write a Kubernetes application that will periodically running and sending all the logs to some third party.
So do you have any idea about Splunk, sir?
I worked on Splunk.
Okay, so using the Splunk, we will do provisioning, data migration.
No, Splunk is for storage. I mean, log storage and all. Generally, it is for what we use for Elasticsearch. Similar way we can use for Splunk.
Okay. Because current which is the customer PwC we are working. So people are talking about Splunk and some other tools, which is the like a as log files or something like that. That's where, as you mentioned.
Yeah, Splunk people use it for storing logs. Splunk
Okay.
has called some agents and all some server. So all the logs are stored in the Splunk server.
So in how many days or how many months that logs will be we can hold?
That is subjective to your project and your requirement.
Yeah, can we store the 1.5 year, 1 year logs?
That's what I'm telling. That is subjective to your application. Some people will keep log only for 1 week or 10 days. Some people keep for a month. That's subjective to your application.
Okay, sir, got it.
That may change. Okay. What is the purpose of log? Tell me.
No, log is purpose of like some kind of issues. For example, we have done the some kind of application hosting, so it's properly running or not, or any errors are coming. So user capturing errors, sister
Yeah.
generating errors. So and
Yes.
on
Yes.
top of
Yes.
logged in those kind of things. As per
Yes.
my view, sir.
Yeah, that's fine. So can we stop the session for today. So this is what about. So we know what is Kubernetes, what is the purpose of Kubernetes, how to do check the basic commands in kubectl using kubectl tool. Next week we will start using some applications, creating some pods using deployment sets, replica sets, creating services, expose the service to the outside world, all the other things we will check.
Sir, this